Thank you. Hello, everyone, and welcome to this session on adjusting pod eviction timings in Kubernetes. Really quick introduction about myself. My name is Andrew Pruski. I'm a SQL Server DBA, Microsoft Data Platform MVP, and certified Kubernetes administrator. I'm originally from Swansea, Wales, but I've been living in Dublin, Ireland for about nearly 10 years now. So I came over from Dublin this morning. I've been up since 3 o'clock. I'm kind of wired. So if I'm talking quickly, I do apologize. My contact details on the slide there, at dbafromthecold and dbafromthecold@gmail.com. So if you have any questions after today, please feel free to reach out. I'm always willing to talk about this stuff. My blog's there as well, dbafromthecold.com, and my GitHub account as well. Loads of stuff on my blog about running pods in Kubernetes and things like that. And then my GitHub account, there's an exact QR code to my repo where all the slides and the code for the demos that we'll be doing today are all available to you. If you want to grab the code, you're more than welcome. So, bit of background. As I said, I'm a SQL Server DBA, and I've been one for well over 10 years now, actually. And I've been running SQL Server in containers for dev, test, and QA for, I'd say, about 5 years. Containers were a real game changer for us in the SQL Server world. When we got new versions of SQL Server, we used to have to spin up a VM, download the installer, install the package, play around with it. And then we'd have to blow that VM away when a new version came out, a new CTP came out, something like that, because they weren't compatible with each other. Those days are gone. It's great now. We get a new version out, we pull the image down, we spin it up, we play around with it, we blow it away. So it works so well, in fact, that I started thinking, can I run SQL Server in a container in a production environment? And started playing around with it, and really it was starting to investigate running in Kubernetes. I did have a look at Docker Swarm at one point, but Kubernetes really did sort of win the orchestration wars, as it were. It was really the main player there. So that's what I've been working with, and having a look at mainly testing in Azure Kubernetes Service. Now, I've used Amazon's offer in EKS a few times as well. I haven't played around much with Google's one. I have built my own Kubernetes clusters. If you want to check out my blog and you want to get Kubernetes up and running on a Raspberry Pi, you can do it. Have a look. It's take you through step by step how to get Kubernetes up and running on a Raspberry Pi, and you can play around with it there. So, also, I wrote an article a while ago about my old company called Ding, based in Dublin, Ireland. This is the company that I deployed SQL Server in containers for their QA environment. They used to have a refresh process of their QA environment where they'd have to blow away all the VMs, spin up the VMs, install SQL Server, and then deploy all their databases. It usually took about 45 to 60 minutes. Got rid of all of that. Got their deploy time down to 2 minutes. A massive saving. And this is what really kicked off my interest in working with SQL Server in Kubernetes, and Kubernetes just in general. OK, so when I was doing my testing for SQL Server on Kubernetes, I started having a look at, basically, I'm DBA by trade. What we basically do is think about how do things break, how do things fail, and what happens when they fail. So I started looking at what happens when a node goes down. What happens to pods when a node fails? Now, this is testing Kubernetes inbuilt high availability. So what should happen is the node becomes not ready, and pods are moved. I say moved, but not really moved. A new pod is spun up on a node in a ready state. However, the default of that takes... How long has that been gone? All right. I'll unplug and replug. Please bear with us. All right, no worries. Well, something just happened with my laptop. We'll try again. Nope. No joy? So we're going to be doing some demos with this session, and I recorded my demos because we're going to be shutting nodes down and spinning them up. But also, I've only got half an hour, and I didn't want to have any demo failures.
You mean you didn't bring a new monitor?
Yeah. There we go. Is that up? Nope. Oh, we'll try another one.
I've got one as well.
Thank you. Oh, let's try this one. Wrong way around. Is that off? No? So we've got two guys at the back here. All right, no worries. They're video demos. I can't play them on. No. It's recorded.
Do you have the presentation, or do you just have the video files?
I have the video files, yes. I kind of need to stop and start, and there's 4 of them, so yeah. Yeah, yeah.
Thinking it was my dongle then.
It's not, no. Let's take this one out.
That was warm.
That does happen, yeah, but where's the... Thank you very much. Let's try it. I don't think it's the USB port, though. It's registered on here when I plug it in. I can see the screen change. Oh, I'm not touching that. Tap. Ah, there we go. Excellent. OK. Sorry about that, everyone. Bit of chaos engineering in action there. That's right. OK, so for those of you who just joined us, what we're talking about is testing stateful apps in Kubernetes. I'm a SQL Server DBA. I was wondering about whether I could run SQL Server in Kubernetes, and what happens when, say, a node fails in my Kubernetes cluster. So technically, all the pods should be moved, new ones spun up on a ready node. But by default, this takes 5 minutes. So OK, for a non-stateful app, who cares? You would have deployed a whole bunch of apps to your cluster. The node goes down. All the other apps take the traffic. Not a problem. For, say, SQL Server, where we can't shard SQL Server across multiple nodes, we have one node with its database, one pod with its databases. 5 minutes of downtime, it's not really acceptable. But let's go and have a look at what happens with the default settings for a non-stateful app. This is me in Visual Studio Code, so I'm just getting myself to the right place. This is not the right video. There we go. OK. So just me setting my location in Visual Studio Code. We're setting a resource group name. This is where my nodes live in Azure. This is against Azure Kubernetes Service. And there is my virtual machine scale set with 3 nodes in it. Your nodes in AKS are a part of a scale set, and that's how you can scale them up, scale them down. So if we do kube control get nodes, there we go. We have a 3-node cluster. OK, nice and simple. Let's see what happens when we start messing around with this cluster. So first thing to do is deploy a test application. We're going to deploy something really simple. We can say kube control create deployment test from an Nginx image. So we're just going to have one pod running in our cluster. Nice and simple. And to prove that I'm not cheating, I'm going to expose that deployment with a type of load balancer service, port 80 to port 80, so I can connect into my application from outside of my cluster and see that everything's working. There we go. That's all good. Right, next thing to do, view everything. One more go, kube control, let's get everything. Let's just see what we've deployed. And we have our pod running, our service with the external IP, so we can use that to connect in. And then we have our replica set and our deployment, all looking good. So just one pod running with a service that we can grab its IP address with that big, long, nasty bit of code, and then drop it into, say, curl, and then connect and make sure we can connect to our application running in Kubernetes. So do a curl against it. Boom, there's the Nginx welcome page. Everything's working as expected. Fantastic stuff. So we've got our app running. We know it works. Let's start mucking around with this. So let's watch those nodes. Let's have a look at them. Say kube control get nodes watch. They're all in the ready state. But now let's jump into a new terminal. Just switch it over. Grab the node that the pod is running on. And thankfully, all we need to do here is just strip out a bit to get the virtual machine scale set name and a little bit of an instance ID. So we've got the virtual machine scale set name and the node ID, which is 9. And we can drop that into a Azure CLI command, and we can shut down that node. So we say AZ VMS deallocate, name, instance ID, and its resource group. We let that run. This part of the video I have sped up, because otherwise we'd be sitting here for a couple of minutes sort of looking at each other going, it's coming down at some point. So we're waiting for it. We're waiting for it. At some point, we will get this node in a not ready state. And there we go. Our node is now down. OK. So let's have a look at that pod. We go and have a look. We say kube control get pods. Well, we'll have a look at the nodes as well. There we are. Status of not ready. And then let's have a look at those pods. Still got the one pod on the node that is actually down. So at this point, our app is down. We can't connect in. We can try curling against it. If we do a timeout of 5 seconds, our app's down. OK, cool. So let's have a look at those pods again. And this part I have sped up again, because the default timeout before that a new pod is spun up will be about 5 minutes. So I didn't fancy we all sit here for 5 minutes ago. I promise it will work. I promise. So I've sped this little bit of the clip up just so that we can see that after 5 minutes, we will get a new pod up and running. So that is the default for pods being spun up on a new node when a node in Kubernetes is reported as down, 5 minutes. And we have the old pod of terminating. And it will always stay in that state while the node is still in the cluster in a state of not ready. we either need to remove the node from the cluster, sorry, or spin the node back up. So jump into the other terminal, do AZ VMSS start, spin that node back up, and again, sorry, chaps. Oh, it's back. Wait. I didn't touch it. There we go. So now we're watching our nodes, making sure, there we go, our node is back up and ready. So that node has been restarted. Confirm that it's there. There we go, all nodes are back up. And then we can have a look at those pods again. So if we have a kube control, get pods output wide, boom. OK, we've only got the one pod. Now that the node's back in the cluster and status are ready, it could report that it was terminated, and we now have our one pod running as before, the default, the desired state of our deployment. And we're testing back in, and we can connect to our application. So that's the default. So that's the default tolerations that we have in Kubernetes, 5 minutes. And for, say, OK, I appreciate Nginx, who cares? You'd have had multiple pods running on different nodes. You could have connected into a different pod, and it would have served the application request. But for SQL Server, for me, as a DBA, that's an issue. That'd be 5 minutes that my pod is, my application is down. I'm getting spammed with on-call messages, getting alerts going, you need to fix this, you need to fix this. So we need to adjust that. Now, there's two methods of doing that. We can, depending on how you built the cluster and the type of cluster you have, if you've built your cluster with, say, kubeadmin, you can set the eviction timeout on the API server. You can set your tolerations for not ready and unreachable down to, say, 10 seconds. You can then run the following code, sudo kubeadmin init, create a YAML file, sorry, sudo kubeadmin init, phase control plane, hit that, deploy that, and that will set 10-second tolerations for not ready and unreachable nodes across everything in your cluster. But the example I'm using, we're in AKS, Azure Kubernetes Service, a managed service. We don't have access to our API server. So what we need to do is actually add the toleration into the deployments. And we can just add these in to our deployment.yaml when we apply it, giving it 10 seconds for unreachable and 10 seconds for not ready. So let's go and see the difference. Here we go, back in Visual Studio Code, just setting my, and we'll have a look at our deployment. So kube control get all, this is the same deployment as the last one. There we go, external IP that we can use to connect in and test that our application is working. All righty, so let's go and grab that external IP and confirm. First thing we do whenever we do stuff like this, test that everything's working as is. There we go, Nginx welcome page. Everything looks good. OK, let's go now edit that deployment and add in those tolerations. So you say kube control edit deployment test, and you have to bear with me here. This is Vim, and who here is good with Vim? Oh, all right, fine. I'm terrible with Vim. So we cut this in. We'll drop down to the spec in the container. There we go. At the end, just before status, not there, Andrew. Next bit, there we go. And we can copy that in. Set paste, for some reason, isn't the default, so drop that. Add that in your own time, Andrew. Thank you, Andrew. And here we go. Save that, right quit, and we have edited our deployment, adding in those tolerations. So now what we can do is, same as before, same as in the last demo, we'll jump into a new terminal, grab the node that the pod is running on, and we'll shut it down. So we'll grab the node, get the virtual machine scale set name, and the instance ID, which is 9. And then same as before, using Azure CLI, just say Azure VMS deallocate, and that'll shut our node that the pod is running on down. Jumping back into the other terminal, and we can watch our nodes. And OK, fully admit, this part of the clip is sped up, because otherwise we'd be waiting for the node to go down for a couple of minutes. So I've just chopped it. There we go. Our node is now down. Excellent stuff. So confirm that. Node's not ready. And now let's have a look at what happens with our pods. I've not sped this part of the clip up. We're watching our pods, and boom, there we go. By adding in those tolerations, we've got those 10 seconds. The new pod has been spun up, our application is back up and running. We can test that if I get rid of that, just to confirm. There we go. We've still got the old pod in terminating state, which will always be that way until we either delete the node from the cluster or spin it back up. But we can confirm connecting into Nginx. Everything is good. OK, so by adding in those tolerations, we've had that new pod spin up a lot quicker than waiting for the default 5 minutes. So this was really sort of starting to tweak my interest when I was thinking about SQL Server and Kubernetes. Can I rely just on Kubernetes high availability? And by the way, in the background here, we're just spinning that old node back up to get rid of the old pod. So we're waiting for the node to come up, and the same as in the last demo, the old pod will be gone. But this was really tweaking my interest. It was like, can I start looking at SQL Server in Kubernetes and just using Kubernetes high availability if I can edit the tolerations like that? 10 seconds to be downtime? OK, it's not ideal, but I'll take it over 5 minutes. So talking about stateful applications. This is where really getting into the meat of it now. The pods need to move to a new node, in a short amount of time. So we've already got that sorted. We've got the 10 seconds, pretty good. But the storage also has to move as well. Well, I say move, but detach from the old pod and attach to the new pod. Otherwise, our new pod, even if it's come across and spun up because of the toleration, that pod will not spin up. SQL's trying to reference storage that isn't there. It's not going to come up. So no mucking around. Let's go straight back into the demos. So same as before. We're in here, and we have a load of storage classes in Azure. We're going to use the default one. We're just going to go for the default storage class. I'm going to create a load of persistent volume claims. And I'm going to create them persistent volume claims. I'm just going to reference the storage. No reference to a storage class. We use the default one. And that'll spin me up my persistent volumes in the background. So we've got 3 of them. Really simple. Access mode, read, write once with SQL Server, and a size of 1 gig. So we'll deploy those. The default storage classes also wait for first consumer, so nothing's going to actually be spun up until I deploy something that's going to reference them. So we're going to create a deployment for SQL itself. Here we go, really simple deployment. 1 rep, 1 pod, the referencing the 3 volumes, and there's where they're going to live. This deployment also, I should have scrolled down further, has those tolerations in it as well of 10 seconds. So let's go and deploy that. And then we can have a look at that storage has been created. Oh, sorry, my bad. We're going to expose that deployment as well. SQL listens on port 1433, so we're going to expose that with a type of load balancer so we can get an external IP address just so we can connect in. OK, so that's been exposed. Let's have a look at our storage now. We've got our PVCs. There they are, all bound, and our PVs bound to our claims. Great stuff. OK, so storage is up. Let's confirm our deployment and our service. So kubectl get all. There's our external IP. Nice and simple. And let's have a look at those pods as well. So kubectl get pods, output wide. Just the one running on the 09 node. Cool, big, horrible, long, nasty thing to grab the IP address. I never do this in real life. I just sort of copy and paste and drop it in, but for demos, it looks kind of cool. And then let's create a database, just so I can show you and prove to you that the storage is coming across. We're going to just use the MS SQL CLI. It's a nice cross-platform tool for connecting into SQL. Create that database, and then do a select name from sys databases, confirm that database is there. And there's our database. OK, so same as before. We are going to go and jump into a new terminal, grab the VSS name, and grab that node. And then we're going to shut down that node. So clear that out. And here we go. OK, so that node is now going to be shut down. Jump into the first terminal and do a get nodes watch. Full disclosure again, this part is sped up, very much so we can just continue on with the presentation. The node is now not ready. Confirm. Yep. OK, that node is now down. OK, so let's have a look at those pods. Do out pods gets right, and I was too slow. That pod is already coming up. We put the toleration of 10 seconds, but it stayed in the status of container creating. This is because of an issue with the storage. The pod has moved, but the storage has not. So if you grab that pod name, and then we do a describe on that pod, we can see what's happened. We can do the describe shows the events of the pod, and we can see we've got multi-attach errors for volumes. The pod is already in use by a different pod itself. And that's where it's going to stay until we do something about that old pod. And the only way we can get rid of it is to spin the old node up or delete it from the cluster. So we need to jump back into our second terminal and start up that node again. Personally, I would just kill the node from the cluster. But for demos, spin it back. So again, waiting for the nodes, and I'm speeding this up again. There we go. Node is now reporting. Oh, come on. Just to keep me on my toes, and yourself. OK, did I skip that on forward? Or? There we go. OK, so the node's back up. And that pod is now still in container creating. It takes a long time. It takes a couple of minutes for the storage to move to the new pod. So again, it's extending that period. And if we have a look now, there's our pod, and it's on our new node. So if we just recap what's happened here, we've created a load of storage using the default storage class in Azure Kubernetes Service. We have spun our pods up. They're all working fine. A node has crashed, something's happened, and started reporting it's not ready in Kubernetes. Because of our tolerations, a new pod has tried to spin up on a healthy node. But it has been unable to spin up purely because it is trying to reference storage that is attached to a pod on a downed node. And that's where that pod is going to stay. It will stay in container creating. Meanwhile, you will be getting paged like there's no tomorrow purely because your application is down. OK, so if we have a look at the pod now, and just to confirm everything, now that the new pod is back up, we can connect in, and boom, there's our database. So not ideal, really. This one has really been having me scratching my head about what I can do about this. So there are options out there. So what can we do out there? And one option I did find is something called Portworx. It's made by, everyone heard of Pure Storage? It basically deploys a bunch of stuff into your Kubernetes cluster that allows to get over this issue. What you end up with is a storage class in your cluster that you can use to create your volumes, and that doesn't have the disadvantage of the default storage class in Azure of the pods, the storage being still attached to a down pod. It will actually move that storage for you, basically bringing your app up if there's an issue with the node that it's running on. So let's have a look at that in action. So starting off exactly the same again, back in Visual Studio Code, set in our location. And then we have the Portworx setup here. OK, so it's not too involved. They do give you step-by-step instructions. Basically, what you do is they'll give you a big, long YAML file that you deploy, and it goes and deploys a whole bunch of stuff. I mean, you can scale it down quite a lot, and it will give you just the bare bones, but you can also implement things like monitoring and stuff, which I would highly recommend you do. But it'll give you a big, long YAML file, and what you end up with, in the end, is a storage class that you can reference in, say, your persistent volume claims or persistent volumes to create your storage. And there we go. We have it down the bottom there. And I'm really bad at naming things, so I called it PX Portworx MS SQL SC storage class. And there we go. And it also deploys. We just check in a whole bunch of stuff there. What it does is it deploys pods to each node. Oh, I missed that. I was just going to point out the restarts of those pods because I've been doing these demos, spinning them up, spinning them down. So that was me breaking Portworx, not Portworx breaking. And here's our storage again. Here's our persistent volume claims. And we go in each time we have, the only difference being this time we have an annotation specifying that we are going to use our Portworx MS SQL storage class, instead of just leaving it as the default. So keeping everything else pretty simple. Read, write once for access mode, and I'm just going with a gig of storage here, just because I'm spinning up a test. I'm going to create a test database that is about 8 meg. So there we are. There's our storage. We can deploy that nice and quickly. There we go. And this isn't wait for first consumer. This is immediate, so storage is going to be there straight away, so we can check our PVCs. There we go, and our PVs. Boom, and I'm going to get rid of that. And there's our claims bound. Excellent stuff. So we have our storage this time. So now we can go and we can create our deployment. And this is exactly the same as the previous one. Nothing different. One big, long, simple deployment, one pod, volumes, volume mounts. Excellent stuff. And, of course, I should have scrolled down further, the tolerations at the bottom. So we create our deployment. And now, same as before, we're going to create a database, so we're going to expose that deployment. Port 1433 to 1433, type of load balancer, so I can get that external IP and connect into SQL Server. OK, there we go. We've got it there. Everything looks good. Our pod is up and running. We've got our service with external IP. Deployment's good. Replica set. We're pretty good. There we go. Pod on node 09, same as before. Great. OK, so grabbing that IP address again, and then this time let's create another database. And this is a database that I'm going to test, again, with the great naming conventions. It is called test database. Cool. Final thing, there we go. There's the database. OK, so let's get into it now. Let's go and switch into the other terminal, and let's shut down that node again. So grabbing the node the pod is running on, grabbing the VSS name and the instance ID of the node, dropping it into our Azure CLI statement, VMSS deallocate, and we'll shut down that node. Cool. Full disclosure again, this is sped up because we've been waiting for a couple of minutes, but let's watch those nodes. And there we go, our node is now not ready. Cool. Excellent. OK, so our node is down. This time, let's have a look at these pods. OK, this is not sped up. There we go. Container creating, same as before, but now, because we're using that Portworx storage class, we have our pod up and running on our new node. So we have our application back up. Our SQL Server instance is back up and running. We still have that old pod in a terminating state, but we have our new one up and running. So let's grab that new pod name. And I made a mistake here with my little command there, so I need to go and change that 0 to a 1. Grab that pod name, and let's have a look at the events of that pod. So kube control describe pod. Oh, get pods. Yep, this is me mucking around because I made a little mistake at the top. Grab the pod name, Andrew. Come on. There we go, Andrew. All right, and now we can describe the pod. Boom. Now, we still get some errors there, which isn't great. But we can see at the bottom there, the pod spanner, and we can connect in. So let's finish off by just grabbing that VMS start, starting up the node so we can get rid of the old pod. Jump into the other terminal, watch the nodes. Again, of course, sped up. There we go. Node is now up and running. Confirm, 3 nodes up. Get pods. Still got that terminating pod there. It does take a couple of seconds for that pod to get, a couple of minutes can do, for the pod to go away when the node is reported as ready. But eventually you'll see a couple of events there. That means that pod is now gone. So if we get rid of that, boom. Our pod is up and running on our new node. And fingers crossed, our database is actually there as well. So we just do a select star from sys databases. Boom. There is our database. So by using tolerations and a third-party option such as Portworx, we can get high availability for a stateful app such as SQL Server, which doesn't have any actual Kubernetes high availability features itself, running up in, say, Azure Kubernetes service. So you can't just use, say, the default settings when you deploy your apps. For stateless apps, not a problem. Stateful apps, you have to consider what happens when a node goes down, your timings for your tolerations, and then what also happens with your storage when new pods are spun up on a new healthy node. OK. So I hope you enjoyed that. I hope that was informative. I've got a couple of links for you here. That QR code will actually take you to my GitHub repo where the slides and all the code for the demos are, so you can go and replicate this yourself if you want to. And I've got a couple of other things there. My blog post talking about this as well, and then the taints and tolerations documentation for Kubernetes. Thank you very much.